Hey guys, well I've been having so much fun with the focus on this refractor of late that I've decided to cave in and get a autofocuser. So I've loosened up the set screw on the knob here and measured the shaft of the focuser. It's a 6mm shaft. Then I bought the Pegasus Astro FocusCube2. This is the second version of their FocusCube, second generation of it. And I'm going to install it and see how it works. This is my first time opening the box. Get a very nice product brochure here. Documentation that you can also download from the web. These are the couplers that I'll link the FocusCube shaft with to this shaft. I think its shaft is 5mm and this shaft is 6, so I need the 5 to 6mm coupler. A variety of screws and washers. I have some of those already. Temperature probe. USB 2 cable. And of course the main element here is the little focus cube and the universal L bracket, which feels like aluminum, and then a power adapter, which I probably won't be using. So there's the key elements. Now, what I intend to do, I've been using this Celestron plate for a variety of reasons, in particular because it fits well with my Celestron mount, but also it's relatively cheap. The nice thing about this plate is there are a number of utility holes here. I've already moved the telescope forward on the plate to its other mounting position to bring this plate back under the focuser. And so it should be a relatively simple matter to find an appropriate mounting where I can tie into the existing holes in the plate here and get this thing mounted up. Okay, the FocusCube2 is installed. It was very easy to do. The bracket that came with is a very good match for the particular setup that I have, so everything worked out just fine. You've got a DC power supply here. You've got the temperature probe here that's included in the package, and of course a USB 2 connection out. I've actually plugged the system in to my USB 3 hub that I use to get all the data into the single USB 3 cable that comes back to the house, and that whole chain worked fine. I'm able to communicate with the focuser. It does rotate the knob as expected. I have successfully linked it up with APT. I've got a few more settings to work on in APT, and then I'll be ready for some actual imaging. But let me just show you a little bit on the connection side what it is that I did. Here is the little link that transitions from the motor shaft to the focuser shaft. And this, in my case, it's the 5mm to 6mm coupler. There are 4 set screws, 2 on each end, that you have to tighten up against the shaft so that it holds it in place. But that works just fine. I was able in my Celestron plate here to find a couple of holes for 1/4-20 screws that I can get through the 8mm wide slots in the universal plate that comes with the FocusCube2, and it's locked down fairly securely with a couple of screws, so that works out just fine. No issues there, and it should be ready to go. Now you'll notice I've got the William Optics 48mm end cap installed on the end of the refractor because I'm currently doing a little imaging project with the Red Cat. So when I have the camera attached to the back end of the Red Cat 51, I take that cap off and just attach it to the end, which is M48 thread, attach it to the end of the field flattener for the Explore Scientific, just to keep dust out. We've got a couple of days of rain here. Then I'm going to finish up the project that I'm working on with the Red Cat 51, the Heart Nebula, and the Flaming Star Nebula. Sometime next week I'll be able to get back to the refractor and do some focusing tests. Okay guys, well the FocusCube is installed on the telescope. The telescope's installed on the mount. I've got a few more cables to deal with, so I'm going to have to work that out later in a little more in a little more care. Tonight, the whole objective is just to focus up on stars and adjust focus as the temperature changes and switching through all the filters. So that's the objective here. I've got the temperature sensors up here, and I bought long cables. I have an extension cable for DC power, and then that goes into my little distribution box here, where I have yet another DC adapter here, plugs into there, a USB cable here that comes out and goes up into the USB 2 port here. So I've got added a few more cables. I'm going to have to rework the routing. What I used to have is just these two cables coming down, but now I've got the other two. I'd have to add those in. But tonight is just a focusing test to see how this thing works. So here are the results of the focusing study I did the other night. I started recording data about 8 degrees C outside when I started. Also, when I started, I wasn't that familiar with the focuser, so I didn't know how many steps to move it in order to achieve focus. So it took me a while early on before I could consistently get focus and knew how many steps to move the stepper motor in order to see a difference. But anyway, I was out there for about 3 hours and recorded data from 8 degrees C down to 4.5 degrees C. And as you can see, there's a couple of areas here where I was able to get all the filters focused at nearly the same time, at least the same temperature. And these are think of these as relative steps. The numbers don't mean much in and of themselves, but the number relative to another number does mean something. Another trend that you see here is that as the temperature dropped, these numbers are decreasing to maintain focus. Now, that's interesting. We'll come back to that in a second because it doesn't make a lot of sense. But anyway, I took these numbers and then went over here to this chart here, which is just taking the luminance filter, or taking this value and subtracting the corresponding in-focus number, step number, focuser position for the luminance filter from it, and did that for all of the numbers in here. So this green area here corresponds to this region here in the table where I was finally getting good working the focuser and getting focus relatively quickly. What this says is, after you take and average out these numbers, you get these numbers. So this number here is the average of this column here for the S2 filter. Likewise, this is the relative offset for the oxygen 3 filter, that is relative to the luminance filter, taking an average of these numbers. Same thing for hydrogen alpha, blue, green, and red. The interesting thing is, and it's a good news, and it should happen, that these numbers are fairly consistent. Notice that all of the red type filters, certainly red, hydrogen alpha, and sulfur, all have the same, in this case, positive offset relative to the luminance filter. Likewise, the two bluish filters, blue and oxygen 3, have a negative offset relative to the luminance filter. Again, you'd expect that. The luminance filter is going to be kind of reading kind of in the green range, with green being in the medium wavelength. And of course, green has the least offset and is in between the blue and the red filters. So these are very consistent results that I can enter into Astrophotography Tool as filter offsets. That way, when you switch to a filter from luminance, it just cranks in the appropriate step value here, and you have a near optimum focus for that particular filter. Now, the other thing that I was going for, and I'm not sure I succeeded, at least not in a way that I understand, I wanted to get a temperature compensation number. How many steps do you move the focuser out, in principle, in order to maintain focus and compensate for the thermal contraction of the OTA tube? So, and what you should be doing is moving the focuser out. However, here's what I found. For higher temperatures, oh, by the way, these numbers here are filtered out from these luminance numbers, and what I've done is taken at 4.5 degrees C, I took the number from 1330, that's the focuser position for focus at 4.5 degrees. For 5 degrees, I took the average focuser position for these values here, and that was 1370. For 5.5 degrees, I took the average of these three values, and then for 6, I took the average of these two values. And when you plot those on this graph, it's a fairly nice line. It's certainly consistent, but it seems to me that it's wrong. I have to figure out what's going on, because what this is saying is that for each degree C, I've got to shift the focuser position 80 steps, but I'm moving the focuser in. These numbers are reducing with temperature, and they should be, in my mind, increasing with temperature. So that's a bit of a mystery that I've got to work out. Now, at this time, I was tracking a star which was moving from the eastern horizon, well, not the horizon, but maybe 40 degrees off of east, altitude in the east, and then moving up towards the meridian. So there is the gravity effect, but I don't believe that should be a factor here. But it's clearly something is going on that is not purely temperature, or there's something else that I'm not quite getting. So I'm kind of looking at this particular number with a little bit of side eye, because I don't understand why it's telling me what it appears to be telling me. All right, let's go over to Astrophotography Tool and show where we can enter in these numbers, if we believe them, into Astrophotography Tool, and look at some of the settings for the FocusCube2 within Astrophotography Tool. Now, if we go over to the Gear tab, the telescope's inside, so it is connected up. At least the focuser is connected up, but it's not outside. I have an image that I've loaded in from the night when I was doing the testing. And let's connect the focuser.
Focuser connected.
And you'll see it pops up with a 5,000 step position. This is a step position. It's going to pop up with that number every time, and I'll show you where that is in the ASCOM settings for the focuser. So here it is. I'm telling it to start from position 5,000. Now 5,000, again, it's just a starting point. It's just a number. It's going to start there every time. So when you finish focusing for the last time in an evening in an imaging session, it'll probably be the coldest that tube will be. The next time you start the astrophotography tool up the next day, it'll be warmer outside, but this is going to read 5,000, and it's going to still be in focus for that colder time when you last refocused your telescope. So anyway, this is starting at 5,000. I haven't put any backlash compensation in. The reverse direction, I have looked at my focus movement, and these buttons here in Astrophotography Tool allow you to type in a number of steps to move, press the button, and then this will move the focuser out, and this moves the focuser in. And indeed, when I put in a large enough value to see, like 500 steps, and press the move out button, the tube does in fact move out. So I do have the correct polarity. Now in my case, the FocusCube is mounted on the left side of the telescope, but if I had mounted it on the right-hand side of the telescope, then I would have had to have clicked this reverse direction box here in order to make sure that a movement out is in fact a movement out of the tube. And finally, you want to, a reason for setting this number where it is, you want to be certain that you're putting some limits on your focuser so that a runaway autofocusing routine doesn't drive the focuser into the stops either way, full out or full in. And so what I've done is define 5,000, knowing full well that wherever focus is, it'll be within plus or minus 5,000. The focuser is not going to move past zero into the negative numbers, so it'll stop there. And then I tell it that don't move past 10,000, so it'll stop there. So I have plus or minus 5,000 steps in order to move the focuser to achieve focus, and that's plenty given the way the system works here. Also, this you leave checked at the stepper motor type as opposed to a DC motor. So those are basically your controls and your ASCOM controls with the Pegasus Astro FocusCube. Now, step size, when you're doing manual adjustments with focusing, I found tend to be kind of correspond to a very fine adjustment, one that where you might not even be able to see movement. And then if you're doing coarse adjustments, you can press this button and that will move the focuser out 5 times this number, so a step of 50, which is on the depending on seeing is observable. So you could actually bump that up to get a larger fine and coarse number here, but that seems to work reasonably well for me. And likewise, these buttons here move the focuser in. And for example, if I have 10 here, for example, if I press move the focuser, you'll notice that the numbers get larger when the draw tube is moving out, and then I can press that and it will go out by a 50 for a large step. So focuser works just fine. It is working in the proper sense, in the proper direction. So that's good news. Now, on the tool side, Astrophotography Tool is in version 3.7 right now, but 3.8 I believe is due out relatively soon, and I think that'll be good because I think there's supposed to be some real improvements with the autofocusing routine. I didn't find their autofocusing routine to work, frankly. The way you use the routine is you find a star, as I have done here. Now in this case the batten-off mask is on it, but the star is so far out of focus that you can't really see the diffraction spikes. And then you would bring up the focus aid. But first you want to go into 1-to-1 mode. So there's 1-to-1 mode, and then you would center the focus aid on top of it. Now in this case it's far too saturated. You'd want to come down, adjust your exposure time so that this number here is not saturated. Also in CCD mode as opposed to DSLR mode, you're working with snapshots rather than live view. And then you would come in with the autofocus aid and tell it to select the half flux diameter or the full width at half maximum. Either one is fine. I tend to want to record the results to see what the results look like later on. And then you would press run, and theoretically this would adjust the half flux diameter to find the optimum number here. Now I didn't find that worked at all. So I didn't get focus that way, so I resorted to using the batten-off mask and the actual batten-off grabber software. So I would look at something more like this, and then I would use batten-off grabber to highlight a large area to identify the diffraction spikes and then judge focus using that. So that's how I went through my focusing study. Okay, so let's go over and look at the settings where we can enter in the filter offsets and, if you believe it, the temperature adjustment. It's over in the Tools area under APT Settings. If you go to the filter wheel, you can see that what I've done is enter in these numbers exactly as I calculated them from my focus study, and whenever I switch from, say, the luminance filter, I'll focus on the focus with the luminance filter, and then whenever another filter is selected, it just cranks in this automatic offset for optimum focus with the other filters. So that should work reasonably well. On the Focuser tab over here, we can tell it that we want temperature compensation and tell it, so you got to check that mark off. And now it doesn't go into an automatic focusing routine when it refocuses. It uses a lookup table based on a temperature, the initial temperature at focus and the current temperature. And this tells it to do real-time compensation, which means even though an image may have started, it will slightly make ever so slight adjustments to focus, even during an image, even while taking an image. Now, here is that number that I don't believe, but I put it in here anyway. The steps per 1 degree change. So in theory, what this is going to do when the temperature drops, it's going to move the focuser out 80 steps. But in fact, what I was finding is that this should be a negative number if I wanted to actually replicate what I had in that table. So this requires a little more investigation on my part before I'm going to believe it. There are some final parameters here which seem reasonable. For example, this is the final move inwards so that you use up any slop in the gears, and you are bearing up against gears so that as gravity takes a greater and greater hold on the draw tube, you are pushing against the stepper motor immediately. So you could put in a number like this. When you adjust focus, it will go past the point of focus and then move in to the point of focus with this step size here. And 10 may be okay. 20 might be a little better. I got to experiment with that a little bit. So one final thing with the temperature compensation, you've got to set a focus mark whenever you focus for the first time. So you go out, you focus for the first time, then you'll come over to this tab here and click it to set a focus mark. Now that records the temperature, which is up here in Astrophotography Tool. It records the temperature that you're seeing, and then from there on out, it monitors the temperature at every 10 seconds, and it takes a 60 reading average for the next temperature, and so that'll give you about a 5-minute period or so of, in this case, the way I have this number set, to check the temperature and possibly make temperature adjustments based on this number that you type in here. So that should work reasonably well. Again, it's not doing an autofocus. My preference would be, and I hope this is implemented in the next version of APT, that you can kick off a good, an effective autofocusing routine, say after each filter change. That would be a nice addition here, something like what SGP has. Also, I would like for the autofocusing routine to not have to rely on the Bahtinov mask. I would like for it to be a half flux diameter or full width at half maximum assessment based on the full star field rather than a single star. But we'll see what they come up with. I think that's one area where APT does need to kind of improve things, and I think that they are working to do that. Well, I found the FocusCube2 very easy to install, and it works perfectly right out of the box. The L bracket that comes with the FocusCube2 is large enough that it's a perfect match for my extended dovetail plate, and I think it's handier to mount it on the dovetail plate if you have one than it is to mount it to the bottom of the focuser, to be honest. But I enjoy the way it connected. It was very easy to put on and work perfectly right out of the box. Astrophotography Tool recognizes the FocusCube2 via the ASCOM driver, and there are no issues whatsoever in getting it to talk with or listen to the FocusCube2. You get the temperature from the temperature probe, and then you're communicating back and forth with the step position. Now, in your particular installation, you might want to be careful of the polarity. I wanted to make sure that when I press the button for the draw tube to go out, it does in fact go out. You may find with your particular installation it goes in, but there's that little check marks that we looked at in the ASCOM driver box that allows you to reverse the polarity, so that should not be a problem. It's easily solved. And right now, APT version 3.7 is not quite ready for prime time as it relates to the autofocusing. I don't find their autofocusing routine to work, frankly. And so I adopted the sort of manual adjustment with the Bahtinov mask, but in my situation, it requires that I go outside, put the Bahtinov mask on, and then come back inside to make all the adjustments, to go back outside to take the Bahtinov mask off. That can be a bit of a beating, so I'm hoping that version 3.8 will solve many of those issues. The focusing study was both consistent and inconsistent. It yielded very consistent results in terms of filter offsets. All the filters that are associated with the red end of the spectrum, behaved one way, and all the filters that were associated with the blue spectrum behaved the other way. The opposite had the opposite sense of a correction. So, in that sense, the results were quite consistent. I don't know what's going on with the moving the focuser out with a temperature drop, because everything results I show is that I had to move it in, which is not what should be happening. So that's clearly something I've got to look into a little bit. And based on the numbers that I've been looking at, I may have to get one of these guys for my SCT just to be able to focus it as temperature changes as well, because that system may be even more sensitive than the refractor that I have. Well, I'll check in with you guys later if I get a little more experience with this FocusCube2 in practice, and hopefully version 3.8 will come out and we'll do a review of it along with the FocusCube2 to see how they've improved the automatic focusing routines in APT. I'll talk to you guys later. Thanks.